Let's solve this problem. A uniform beam PQ of mass 20 kg and length 5 meters is balanced as shown below. A man of weight 800 Newton stands at M such that QM equals to 2 meters. 2 meters. The reaction at P and Q respectively are what? So that is what they want us to calculate. But I want you to remember that a force can make a body to move on a straight line like this, right? And a force can also make a body to turn about a point like this. So the turning effect of a force about a point is what we call moment. So this question is from moment. Now, we are going to be using the principle of moments to solve this problem. Now, without wasting much of our time, the first thing we are going to do here is that the mass of the beam was given to us, so we are going to use that to calculate the weight of the beam. We are going to use this to calculate the weight of the beam. So we say weight of beam is equals to mass times acceleration due to gravity. So which is going to be 20 times 10 because G is 10. So that is going to give us what? 200 Newton. So that is the weight of the beam. Now the next thing we're going to do now is that we're going to redraw this diagram and we are going to mark the distances appropriately. Now, the beam PQ, I'm going to draw it just using a straight line for conveniency. So here is going to be our beam PQ. So this is our Q and this is our P. Now, we have a point M here. So we have a point M here like this. And the distance from here is just 2 meters. So we have 2 meters here, right? Good. Now the next thing is that we have the total distance from here to here is 5 meters. Please don't forget that the distance from here to here is 5 meters. Now remember, go back to the question. A uniform beam. Now this word uniform means that the weight of the beam that we calculated here, this weight of the beam, acts at the center of that beam. The weight of the beam acts at the center of that beam. Why did we say that? Because the question says a uniform beam. So we have a uniform beam, so the weight of the beam is going to act at the center. And since the total distance, okay, now let me put this like this. Remember that from here to here like this, 5 meters, from here to here like this is 5 meters. From here to here is 5 meters. So meaning that the weight of the beam is going to act at the center of the beam. So what is the center of 5 meters? That is going to be 2.5 meters. So I can say that the weight of the beam, let it act at this point. Let this be the center. So this is the weight of the beam. So it's going to be 200 Newton. So, and I'm going to do that. I'm going to do something like this, that the distance from here is 2.5 meters like this. You can see like that. Because the question says uniform beam. So we calculated the weight of the beam itself and it gave us 200 Newton. Now, the weight of the beam is, because the beam is uniform, it's going to act at the center, and I've drawn that myself because the question didn't draw it for us. So now, remember that the total distance from here to here is what? Is 5 meters, right? And from here to the center is 2.5 meters. So, and remember, a body The question says, a man of weight 800 Newton stands at M. So the weight here at M is, let me put here, 800 Newton. So the weight of the man at M is 800 Newton. I hope you can see this. Now, the distance from here, this point, here like this, to this point is going to be what? Since from here to here is 2.5, and from here to here is 2 meters. So from here to the center has to be 0.5 meters. I hope you can see that. 0.5 what? Meters. So we can see this. So having known that, then the next thing we are going to do is that we are going to apply the principle of moments to this question. Now, what is the principle of moment? What does it state? The principle of moment states that the sum of moment, clockwise moments about a point, the sum of clockwise moments about a point is equals to the sum of anti-clockwise moments about the same point. So what we are going to do now is that we are going to take moments about any convenient point of ours. So in this question, I'm going to be taking moments about point P here. I'm going to be taking moments about point P. So meaning that this is, let this be my point P. Point P is going to be my turning point, like this. So now, if you want to take moment about point P, then you have to look at all other forces that are acting here like this. We have 1, which is the weight of the beam. Here, 800 Newton, which is the mass of this man, and also the reaction at Q here. Those are the 3 forces now. Now, let us look at those 3 forces. Which of them is turning the beam, is going to rotate this beam in a clockwise direction? So we know which one to find as the clockwise moment, and which one is going to rotate the beam in the opposite direction, which is the anti-clockwise, so that we know the one we are going to take as the anti-clockwise moment. Now, if you cover these 2 forces and you look at this weight, now look at the direction of the arrow of the weight. Look at the direction of the arrow. Now, how do you see that it's facing downward like this? So it has the tendency of rotating this beam about this point like this, like this. And when something rotates like this, it rotates like this. That is clockwise. So this 200 Newton is trying to turn, is going to turn this beam about point P in a clockwise direction. So what about this weight of this man, which is this force here? Now, this 800 Newton, the weight of the man, is also going to turn this, you can see it's also facing downward here, right? So meaning it's going to turn this beam also in a clockwise direction. You can see this. If you cover this and you cover this and you look at only this, you know, it's going to turn this beam like this also, which is also what? Clockwise. Can we see? Which is also clockwise. Now, what about the reaction at this point? Now, the reaction at this point is going to try to, you can see the direction. You can see the direction of the arrow. So it's going to turn the beam like this, just like this, as if like this. So now, this is like this, and that is anti-clockwise. So we know the forces that are clockwise, and we know the forces that are anti-clockwise. So according to the principle of moment, sum of the clockwise moment about a point equals to sum of the anti-clockwise moment about the same point. Now, I'm going to take the clockwise moment of this force now. Remember our moment. Moment is equals to force times perpendicular distance of its line of action from that point. Now, meaning that this is our force, right? This is our force. Now, this is the turning point, which is, I'm taking moment about this point. So the distance from here to that force, that is, you can see that the force is like this, then the perpendicular distance is like this. So they are at angle 90 like this. That's what we are saying. So here to here is 2.5 meters. Can we see? So we say the force, the moment, the clockwise moment, this 200, the force times perpendicular distance, which is 2.5 meters, right? Now, remember, it is not only this 200 Newton that is trying to turn this beam clockwise, right? Also, this 800 Newton of this man is trying to turn this beam also. So we are going to say plus, because the anti-clockwise moment is yet, the clockwise moment is yet to finish. So meaning that this is going to be force times perpendicular distance. Now, what's going to be the distance from here to the turning point here? Remember, this is 2.5, and this is from here to here 0.5. So meaning that is going to be 3, right? 3 meters. So we're going to have times 3, right? Now, we have these two. These are the two clockwise moments that we have. Now, and don't forget the principle that sum of the clockwise moments is equals to sum of the anti-clockwise moments. So about the same point. Now, this Q is the only one trying to rotate this beam in an anti-clockwise direction, right? So this Q, the reaction Q times what is the distance from this Q to this turning point? It is actually the total distance, which is here, which is 5, right? So we can try to solve this. 200 times this is going to give us what? This is going to give us 500, right? Plus 800 times 3, that is going to be 3 times 8 is 24, 2,400, right? Equals to 5Q. Am I right? 5Q. Then we can say this plus this is going to give us 2,900 equals to 5Q. Then we can divide this by 5 here. So once we divide this by 5, we're going to have our Q. So our Q is going to be equals to 5 here. 5 is going to be 5. Remainder 4. So here, that's a 40 is 8. That's 480 Newton. And that is our reaction at Q. Now, in addition to the sum of clockwise moments is equals to sum of anti-clockwise moments, there's also another principle which says that the sum of upward forces is equals to the sum of downward forces, or the sum of forces in one direction equals to the sum of forces in another direction. So what we are saying is that all the forces that are acting on this beam, the sum of those ones that are going up must be equal to the sum of those ones that are coming down. So meaning that here, this reaction at P and this reaction at Q, they are the ones facing up, going up like this, like this. But this weight of the beam and this weight of this man is coming, they are coming down, right? So we say P, we then say P plus Q must be equals to 200, which is those ones that are going up, must be equals to those ones that are coming down, which is plus 800. So that is going to give us P plus Q. What is our Q? That's plus 580 rather, must be equals to 200 plus this is going to give us 1000. And our P is going to be equals to 1000 Newton minus 580. So that is going to be, our P is going to be equals to 420 Newton. Now, remember what the question asks, that P and Q respectively. So it means that you have to mention P first. So that means P and Q will be equals to, our P is 420 Newton, comma, and our Q is what? 580 Newton. Now remember that when you took the moment about the point P, we got Q, right? Now you can also choose to take the moment, another moment about point Q, and you get P. But that is going to waste your time rather than using the second principle here. Thank you.